Right, so good evening to my friend. Welcome back to RoboCup at Home Education, RoboCup 2022, Bangkok, online classroom, online platform. So I'm Jeffrey, and together with me is fellow engineers from Jupiter Robot. So we welcome you back to our second class for open platform development. Okay, so this is the arrangement for today. So today we will move to the second class, and we will start to introduce the first robot function that you can develop for your service robot. Right. So today we will talk about the speech interaction, and similar to our usual arrangement, we will divide this session into two parts. So part A, we will talk about speech synthesis, which is how you can develop a robot to say something in a natural human way of speaking. Okay, so speech synthesis. And then for the second half, we will have speech recognition. So speech recognition is to develop the robot so that it can recognize what you say. So these are the two parts that is very important if we want to develop things like chatbot or interactive robots for a lot of application. Okay, so today we will show you how to develop this with a very simple system that we have set up last week. Right, so first thing first is like, okay, so as usual, we have a meeting link there. So it is actually on a website as well. So just in case anyone still on the way, your friend, your colleague, your student, or anyone, so they can refer to the website. Okay, so down there listed, the first link is our website. So over there you can find the information about all this online classroom. And then if let's say this is the first time you join this class and you haven't signed up, so remember to sign up and enroll to this course material for today, which is you can find the course material from the second link. And also the video recording for last week class, we already like uploaded together with the slides. So if you access the course material link, you can find the video and also the class materials that we presented last week. And lastly, if you have any question you want to ask, you want to discuss or anything, you can head to our class group and start a discussion over there. There's a forum there that you can discuss with us. Right. So I can see many people are coming in. Okay, so just as a reminder, please turn off your camera and also your microphone because the whole session will be recorded and we will upload this video online. So it is currently available in our course materials. Of course, as usual, it is available in our YouTube channel as well. So please turn off your camera and also your microphone unless you are told to do so, or during our Q&A time, which is usually we will have Q&A time in the interval break and also at the end of the session. But of course, throughout this whole session, if any part that you face any difficulty that you would like to ask, yeah, feel free to interrupt me and ask the question. Okay, so no problem. Okay, so this is the arrangement for today, and we are going to start the first half, which is we'll talk about the speech synthesis. Okay, so still many people are coming in. I hope everyone can settle down, and we are going to start very soon. Okay, so for anyone that just joined us today, the first day, so welcome to our class, and this is our arrangement. I hope you can settle down. So just take a photo of this, and you can check out the link later on. But the important link is the first one, which is you will head to our website about this online classroom, and you're supposed to be able to find everything over there. Okay, right. So just before I start, I would like to invite our co-host, our committee from Thailand, to have a short greeting with the audience. Then before we start, is that okay?
Hi Jeffrey, can you hear me?
Okay. Yeah, just tell them about the arrangement, where to find the slides, and we are going to start. And also turn off the camera and also microphone so throughout the whole session, unless during Q&A.
โอเคครับสวัสดีครับก็สำหรับวันนี้นะครับที่เขาจะมาสอนเนี่ยจะเป็นในส่วนของspeed เนาะโดยที่อันแรกเนี่ยที่ชื่อว่า speed synthesis ก็คือถ้าเราคุ้นเคยกันก็คงจะเป็นtext to speech เนาะก็คือเรามีคำพูดไปแล้วก็ให้คอมพิวเตอร์เนี่ย generate เป็นเสียงพูดออกมาเนาะส่วนอีกอันนึงจะเป็นspeech recognition นะก็คือจะเป็นในส่วนของspeech to text นะก็คือเราพูดขึ้นมาแล้วก็เขาก็จะไปทำการทำให้มันเป็น text เนาะแล้วก็ในส่วนของลิงก์ข้างล่างนะครับก็ถ้าท่านใดหาสไลด์เนาะก็สามารถที่จะกดเข้าไปในลิงก์ที่เขียนว่า course material ได้นะครับแล้วก็ใครที่เพิ่งมาจอยครั้งนี้ครั้งแรกเนาะก็สามารถที่จะกดลิงก์ไปที่ online classroom นะครับก็คัดลอกลิงก์บนหน้าจอเนี่ยครับไปวางใน Google ไม่ใช่ครับขอโทษไปวางบนเบราว์เซอร์นะครับแล้วก็สามารถที่จะค้นหาได้นะครับทั้งข้อมูลทั้งหมดแล้วก็อีกอย่างหนึ่งที่เขาฝากมาเตือนนะครับก็คือเรื่องการเปิดกล้องแล้วก็เปิดไมค์นะครับขอให้ปิดกล้องแล้วก็ปิดไมค์ด้วยนะครับยกเว้นในส่วนที่เป็น Q&A session เนาะโอเคครับโอเคเจฟฟี่
All right, thank you. Okay, so let's start the first session. Okay, so for today's speech interaction development system, all you need, okay, the materials that I'm going to introduce you is very, very simple. I mean, like we only use very basic thing that you can find around you. Okay, so for the hardware, what you require is basically just your laptop or you are using a desktop, just any PC. And then that come with microphone and also speaker. Okay, I believe now all the laptops come with microphone and speaker. Okay, so it should not be a problem. And that is all you need in order to follow the class. So even though today you are the first day that joined this class, don't worry about the software. If you haven't installed anything, you can still catch up. You can still find our materials, class materials, and also recording from our website. So no problem, you can still catch up. And later on, I will also show you some temporary measure that you can do so that you can follow the class as well. Okay, so the software that we need is basically the Ubuntu system that you have set up that we have discussed last week. So whether you are using a VirtualBox or a dual boot, or you have applied for our virtual desktop. Okay, so either way is fine as long as you have this Ubuntu system. And then for the ROS system, so we are using Ubuntu 18.04. So you're supposed to install ROS Melodic together into the system. And that is the system setup that we are going to use for today. And then for other related software, which I will introduce today, the related software and also some sample code that we are going to use for our speech interaction. So don't worry if you haven't installed any of those. I will show you what are the package and where to get those things and how you put it in so that we can work together. Okay, so I hope the system is ready in front of you so that you can work out along with us together. And if you face any difficulty, you have any question, I will try to have some interval during my explanation and you can ask the question during the interval. Okay, right. Okay, so important thing is please, let's do it together, okay? Okay, so for speech synthesis, in a very simple term or widely also known as text-to-speech. Sometimes you just read TTS, okay, text-to-speech. Okay, speech synthesis is the production of artificial human speech by a computer or other machine. So it is very important that we try to make our computer or machine or robots, okay, able to produce sound that can speak very similar like us. Okay, so this technology is what we call speech synthesis or text-to-speech, which is we input with a given text, then the machine or the robot will try to transform and try to read it out using human voice, like what I'm doing now. Okay, this is a very important technology so that the machine or the robot able to interact with a lot of people who are not familiar with, for example, more technical way, for example, like type a command or press some button, just in case like you have so many buttons. So normal people might don't know which button belongs to which function. So the way how the machine can interact with the human is by using natural speech. Okay, so that is the most natural way human interact with each other. So this is a very important, especially for us, that when we build a service robot, okay, because service robot is supposed to serve the general public, which is majority or most of the case are not very technical competent. Okay, so in order for a robot to deliver the duty, so a lot of time it need to like interact with normal people. Okay, so it is very similar, like for example, you have a receptionist robot, for example, or you have a robot that in front of your retail shops that try to explain to the customer and so on. So this speech synthesis, the application is you can find it everywhere, many places. And now even not a robot, just a normal PC or even your phone have very similar function. Okay, right. So it also knows as text to speech. So to make things easy, we always call it TTS or text to speech, which is we input text and then the system will convert it into spoken language. Okay, so normal language text is converted into speech. Right, and this process might sound very simple, but actually a lot of things happen in, inside the system. Okay, and later on I will show some example that we might don't realize, but a lot of analysis, a lot of process is undergo when we convert text to speech. For example, below here I put a diagram to show you some component that we need to consider or we need to process the text before we can actually generate the speech. For example, the first thing is text analysis. So text analysis basically is to analyze, like, for example, how many characters you have, how many words you have, how many phrases you have, how many sentence that you have over there, right? And then are they English, or are they in alphabet, or are they in other languages as well? So you need to analyze the text overall. Okay, so once we know the text, then we try to find the grammar, okay, or the words. We try to understand the words and also the grammar inside there. So, and during that time, we also need to look at, for example, the punctuation mark. For example, like, is this a question or a statement, or it is a greeting, or sometimes you can see exclamation mark, which is the intonation will change. Okay, so these are the linguistic analysis. We try to understand the grammar so that we can generate appropriate intonation. So when we want to convert from text to speech, it is not just to read out, but we need to read out with a correct manner. Okay, so for example, like when we want to generate the waveform basically is like, for example, we create a waveform that it will, when we play the waveform, it's very similar like we play a music form or we play a sound file, which is the waveform, then it actually create the sound. Okay, so the text analysis actually tell us or tell the system how to create appropriate waveform. Okay, so for example, like you have the words, you know how to read it. Okay, so from the library, we have all the way how to read a certain words. But when we put them into a sentence, okay, we need to see, like, for example, our intonation. If it is a question or it is a statement, it can be the same text. A question mark behind or a full stop behind or an exclamation mark behind will actually change the intonation or change the way how we express the same sentence. So these are all the things that happen inside text analysis, but we are not going to go deep into this. Okay, but if let's say you want to, for example, like write your own speech synthesis software, then there are actually many things for you to consider. And then there are many, like in terms of linguistic side, that you need to consider. So these are all the parameters that you need to consider before you can come up with the appropriate speech or the sound that represent the speech, right? Okay, but today we are not going to go very detailed into this because like each of them is a field, is a domain by itself. So what we are going to do is we will use the system that we have and also the hardware and the software that we have, try to see how to develop a system that can convert from text to speech. Okay, so this is what we are going to do. Okay, so first thing is let me introduce the software that we use. Okay, the software that we use. So we're using this festival. Okay, you can click on the link and then go to the website of this festival to explain to you the software that we use in order to do the speech synthesis. Okay, so the way how we arrange the class is always when we introduce new function, we will first introduce a related software package. For example, what kind of software that we use in order to achieve the particular function. So we will first introduce all those related packages, software, and also library. Okay, so we use a lot of those things. Okay, so to build robot, it is not possible that you want to build everything from scratch. Okay, so a lot of time we refer to other software, we refer to other library and so on, and we build function based on the function that's already there. Okay, but that is also the advantages of using open source materials, because like we can actually refer to many very good software and then we try to assemble those fundamental function and develop very advanced or more advanced application. So this is what we're trying to do. Okay, right. So the first thing I introduce you, the festival is the software in Ubuntu that we use to generate the speech. Okay, then in order for this software to be workable or in order for us to develop this inside ROS, we need a wrapper. Okay, we need a wrapper. So this festival is a part of software within the Ubuntu system, and then we have this sound play. You can click to the ROS wiki to look at the sound play. So the sound play actually wrap this festival function so that we can have the API in ROS that we can call it, and also we can work it on inside the ROS, which is we already have a lot of API and so on. And down there, I put a link to the tutorial for SoundPlay, which is very, very relevant to the example that I'm going to show you later on. I strongly advise you to have a look on the tutorial because you can find a lot more ways to use this SoundPlay. Okay, but we already like extract some of the very important part that we frequently use in our development for service robot that we are going to show you in terms of the example. Okay, then after I finish introduce the related software or related software packages, I put out the link so that you can refer or can read more after this. Okay, so the first way of showing you how to use it is I will show you the command line operation. Okay, command line operation means I'll bring up the terminal and then I'll show you like some command line that you type in and then you can see the effect. Okay, so this is the command line operation. Okay, then because all our software are open source, from the ROS basic that we learned last week, you know that ROS run is basically to run a node, and a node is basically like a Python file in this case. And then you can see the package name in front. So with this format, you can actually find the original Python code from the system. Okay, so after you install everything, and then when you refer to the command line that I show you here, you can actually slowly find where is the original Python file that you can actually open up and see what is inside and how it actually use, for example, the library or the software that we introduced just now in order to develop the application that we want. Okay, and then that is for the command line operation, so that I can show you the functionality of the software that we are going to use. Okay, here. Then the next thing normally we will introduce is the source code implementation, which means we will use whatever functionality that we already obtained from this from the command line operation, and then I show you the example that we developed in building our service robot for at home development. Okay, so which is down there you can see like RC home edu speech. So this one is actually from our GitHub repository. So the example of a speech example, and then under that we have the script folder, which is have all the Python part inside there, and then the sound test.py is the example that we are going to use, and you can actually rewrite or reuse this sound test example in your robot application. Okay, then this is the source file, the Python file, and then the way that we package into the launch file, you can see down there. So we got the ROS launch, and then in the same package, RC home edu speech, and then we have the sound test.launch. Okay, so this is the launch file that we already arranged nicely. You can actually reuse this by itself, but sometimes you might want to change the Python file, and then or you change the functionality, and then you can develop your own file. Okay, so that is the explanation of the outline. So now I'm going to show you step by step, one by one, the file. Okay, correct. Okay, so first is like, let me, okay, change my display so that I can show you, sorry. Okay, so that I can show you the, my system. Okay, so let me stop my, okay, stop this. Okay, right. Then I'm going to show you here. Right, so now you have my screen over here. Okay, so let me show you. Okay, so this is my desktop. Okay, so it's a Windows. So today I will use the virtual, sorry, this one, yeah. So this is my virtual desktop by Robot for All. Okay, so some of you already like apply for the beta tester. Okay, so I'm going to show you how to use the remote desktop now. Okay, and for the rest of you, if you are using your own Doboot or your own VirtualBox, right? So this is the time that you can refer to your Ubuntu system. Okay, so let me close this and let me show you how. Okay, so this part, I'm going to explain how to use our virtual desktop in order to connect. So first is from a Windows system. So I'm having a Windows system. So I go to the remote desktop. You just search remote desktop, and then it's supposed to be come together with almost all the version of Windows. You can find this software. Okay, okay, I need to like put it in first. Okay, so you can have the remote desktop here. Wait, let me see again. Okay, right. So the first thing you need to do is you need to specify the IP address and also the port number, which is for those that successfully selected as a beta tester, you're supposed to receive the email containing this information. Okay, so just put in the IP address and also the port number of your beta testing account. Right. Then down here, there are actually many options that you can choose. For example, like this one is okay. Username, you can type it later, so you just leave it here. This one, just leave it here. Just important is you type your the account that is given to you. Okay, right. And then the display, how big you want, because I'm going to use I have a small display, so and I'm going to show you a few things. So I keep it small, but of course you can put it larger, or you can even put it full screen so that you can have the full screen of the display for you to work on. Okay, right. And then this is how much color you want. I mean, like how true or how nice the color. But usually I will recommend you to keep things simple, okay? To have a small display and also to have not very high color. So in order to save the resources, because the resources in virtual desktop is very valuable. You want to use it mainly for your process, especially when you run something very heavy. Okay, so that is usually you can save your resources by putting small setting over here. Okay, right. And then today we are using so we want to do the speech recognition, right? And then speech synthesis. So we need to share our local resources. For example, our microphone and also our audio playback. So audio playback and also audio recording. So you want it to be played on this computer. So which means later on you can hear the sound from the speech synthesis on our local machine. Okay, so you play on this computer, and also you want to share because like your local mic is going to capture your voice and then send it or share it with the server, right? So you need to put this. So if you put this, then yeah, your speech synthesis and recognition will work. Okay, right? So it will share between your local machine and also your virtual desktop, right? So this one, you check this one. And then the rest should be fine, okay, no more. Okay, then the rest should be okay. Okay, you can check this clipboard so that we can have cut and paste working between your local machine and then also your server, right? Then I connect, right? So, okay, you just agree with all the things, right? Oops. Okay, maybe my network is busy. I hope you can connect. Oops, it's not ready. Wait. Let me see, did I change anything? It's supposed to be okay. I think it's because of my network very busy now. Oops, what's wrong with... Okay, let's change another server. Oh, okay, I think I chose the wrong one. Yeah, I choose the wrong one. Okay, so make sure you choose the correct server, okay? Right. For this session, don't change, okay? Use this XORG. Okay, for the username and password is already given you in your email, so you just type in the username and password that's given in the email that's sent to you. And yeah, then I have my remote desktop. Okay, so this is similar to the system that I showed you last week that I run the publish subscribe, if you still remember. So it's the same system. Okay, first thing I want to check is the speaker and microphone. I want to make sure that it is working. Okay, so I open up my launcher of my mixer. So the output device, okay, this one looks okay. It appears, so which means it has is running. Okay, and the input device, which means it actually pick up my sound. So can you see this bar? So which means whatever that I say now is actually captured by my local PC microphone, and it is sent to the server. Okay, because this one, the one outside is my local PC, and the one in this frame is my server, my virtual desktop. Okay, so yeah, it's working. So this is good, right? So I'll keep this thing here to make sure that this is working, to remind me that, okay, it is picking up my voice. Okay, right. So I open up my terminal. So this is something that I'm going to use and run it together. So I take up my, okay, this one. So I need to open up the course materials for today. So you go to speech synthesis. Okay, put it here. Right. Okay, so I hope, okay, so everything's setting up nicely. So I have my materials, and also I have my machine to try on. Okay, so now I hope everyone have the same setting. you have the materials in front of you, and also you have your Ubuntu with you. Okay, so now let's do it together. Okay, so first thing is we're supposed to do is, okay, this command lines operation. Okay, so command line operation, first thing is ROS call. We don't do anything, we start with ROS call. Okay, especially when we don't use the launch file, we need to start with ROS call. Okay, so everything runs smoothly, nicely. Okay, then open up another terminal. So I run the sound play. So ROS run. Okay, so this is the command to run a node, and then sound play. So sound play is the package. Okay, so the format is ROS run, and then the package name, and then under the package name, we need to type in the node name. So this is the node name. Okay, so the node soundplay underscore node.py. Okay, so when we run this, okay, so it says sound play node is ready to play sound. So now we already like bring up. Okay, so bring up is the words that we always use, is to bring up certain function so that it is ready to do something, right? So the next one is we need to give the instruction what to do, okay, with the function. Okay, what to do. So ROS run, and then sound play, and then say. So it got another node which is going to communicate with the sound play node to pass the string or whatever sentence or line that we indicate as the argument here for the sound play node to convert it or to generate the speech from the text that we input. Okay, so for example, now we put in hello world, for example. Okay, so hello world. So this one means this text is going to be input into this node, which is going to send this to the sound play node, right? In order to be converted using the festival software, to convert into the voice file, okay, wave file, okay, and then it will read it out. Okay, so then you can hear the hello world. Okay, so I'm not sure if you can hear me here, but I will run this and please listen carefully. Okay, so I can hear my speaker actually have the robot sound that say hello world. Okay, and then it also give me the result that the saying, okay, so the word that the machine say out is hello world, and then it is using this voice call diphone, which is the voice profile, and the volume is set to 1.0, which is the same as what you set in the mixer. Okay, so this is the output that we get. Of course, we can do something longer. For example, hello, how are you? And then we can hear this as well. Yeah, so I can hear this, right? And this is totally done by the software and also my machine, right? So because here, okay, one thing that I forgot to explain up to this point is the technique that we use now is the offline. Okay, so what is offline? Later, I'm going to show you the online way. Offline means everything is processed on board. So all the process and everything is run on your local machine. Local machine, not my PC, but this virtual desktop. Okay, which is it don't actually use any cloud resources. For example, I use Google API or Web Speech API or anything. Those kind of software or services are what we call the online method, right? So over here we use the offline. So everything is done by the robot, okay, or the process or the computing unit of the robots. Okay, and this is very useful, especially when our robot is not connected to the internet. Okay, so this is the way that I show you how to do this without actually using internet in order to have the speech synthesis. Right, so here we show you the example. Okay, then we want to look at another the actual example that we use in our application. So let's look at this one. Right, so I open up another thing. So I'm going to, for example, like I want to show you where is this thing. So I think by now you know what is CD. Okay, and then we already create this catkin WS. So last week I showed you that we need to create a package. If you still remember, one of the assignment that assigned to you is to create a package and create your workspace, and then create a package in your workspace, and you create your publish subscribe. Okay, so that is the assignment last week. Okay, so over here, Catkin WS is my workspace, which is standard. We follow the ROS tutorial. Okay, so under this, under my Catkin workspace, I actually have several files, and the important one that I want you to take notice is this source. Okay, so I will enter my source folder to see all the packages that I create here. Okay, so these are all the things. Okay, so because this one, I'm using the Jupyter OS, so we have a lot of other other packages that give us more functionality, but at least you need to have this one, RC Home EDU Learn ROS. Okay, this one is from our GitHub, right? So GitHub okay, this one. So if you go to our GitHub, this is the example, our repository of our example that we use for our online classroom. Okay, so we have the apps. ARM we are not going to use for this series, and then mapping we are not using. Okay, but we use the navigation, speech, and vision, right? So these are the things. So remember to git clone this and put it here, right? So today we use one of it, which is the speech. Okay, today we are going to use this, right? Okay, so over here, okay, so every time when you git clone, then you need to like catkin make. Okay, so I believe you already done that. Okay, so let's go into the speech. I want to show you the example. So cdr speech, right? Okay. So in the package RC home speech, so this is a package example that we provide you from RoboCup at Home Education. So inside here we have the launch folder, the RoboCup folder, which is some dictionary file or configuration file, and then we have the script with which contain all the Python code, right? So we go into the script. Okay, and we have all this thing, right? So go back and refer to this thing. Okay, right. Okay, so for all the newcomer, just in case that you want to work on it and you haven't applied for the beta testing, you can come. Yeah, you can go to this page, which is my workspace, and then over here we have 10 account that you can use, but this is web-based. Okay, which is it don't come with a lot of function. For example, you can't hear the voice because this web system can't really connect to your local resources. But at least you can do something like, for example, what is learn ROS. Yeah, you can see things like that. Okay, very similar. You can see something very similar, but this one you don't have anything. Okay, everything is empty because this is just for you to practice to learn ROS. So if you want to do ROS thing, okay, you can use this. And if you want to do things that I show you now, yeah, please apply the virtual desktop or you set up the system by yourself, right? Okay. Okay. Oh, over here now we are looking at this. So we have the soundtest.py over here. So this is the original source code that we use for this example. And also we have another one which is TalkBack. Okay, TalkBack I'm going to explain after this, but now let's focus on this sound test. Okay, to open up this sound test, right, you have something like this. Okay, don't worry about this, but what I want to show you is if you are not familiar with Python, then you need to do some homework in order to learn how to read this. Okay, but if you know Python, then should not be any problem for you to read this. Okay, so I'm not going to read all the lines, but what I want to show you is the important one. Okay, so we import the ROS.py OS, which is to use the the command line function, and then the system. And from here, we have the sound play message, okay, which is we import the sound request and so on. And then from the sound play again, so we use a lot of sound play library over here. Okay, we create the sound client and so on, right? Okay, so this one. Then we have a sleep function. We define a sleep function using the ROS-py sleep. Okay, so the main one is basically, yeah. So if you have practice and done your exercise on publisher and subscriber, you should be familiar with this format, right? And then you have this you initialize the node, okay, this one. And then you create the sound client, the sound handler, and so on, right? So the important part over here is just this few line, and until here you can see the sound handler dot say. So this one, the dot say, is very similar like just now the say.py. Okay, so whatever line that you put in using this function, you can read out the hello world or whatever string you put in. Then another function is the display wave. So display wave, you can play a wave file. Okay, so if you have a wave file or you put a wave file there in your system, you can use this to play a sound, okay, or wave file, or you can use this to directly do your TTS, which is your text to speech. So this is text that you input, and this one is to read out the text. And also you can see the sleep here. So this sleep function is a delay, so that it will delay 3 seconds in order for the system to read out this line before it proceeds to the next one. If without this sleep, maybe before it finish the word, like hair is already jumped to the next one, then it start to play the sound. So you cannot actually finish, the system can't actually finish saying hello world before it proceed to the next line. So you need this sleep to control the delay so that this node will read out the words or sentences that you put in. Okay, then the rest is, for example, some sound effect. Okay, so these are not very important, but I put it here. So from the tutorial, so that you know in sound play, we actually have a lot of API for you to use, right? These are all the API that you can use, and also different way of writing the API or using the API as well. Okay, but if you just want the robot to say something, all you need is up to this line. That's all. Okay, so these are how. So every time when you want to make your robot say something, you just write a file like this, or you can copy this file and then write until this point, and that's it. You run this file, and then your robot will say the things that you want, right? And you can even incorporate this part into your main program or other program, so that you can make your robot program able to say something. Okay, so this is as simple as this. Right, so this is all sound for sound tests. And then I also want to show you a little bit about the launch file. Okay, so I go out a bit, view the launch file. Okay, so over here we have the soundtest.launch. So let's see the soundtest.launch. Right, so it's as simple as this only, right? Okay, so launch file in ROS1 is an XML file format, right? And then this one is just a command. So this launch file runs the sound play node and a test script that exercise most of its functionality. So the sound test script is just the script that I just showed you. And also it runs the sound play node. So at least 2 nodes are executed when you run this launch file. If you still remember in last week's class, a launch file is used to run multiple nodes. Okay, so this over here we have 2 nodes. The first one is sound play node under the sound play package, and type is basically the file. Okay, the Python script. Right. Then the next one, the node name is called sound test, and then it's within the package of RoboCup at home education speech package. Okay, so this is to take the package, and then the type is the sound test.py. Right, and this output screen is basically any feedback that if you run this sound test.py on a terminal, any feedback that will appear on the terminal, this output screen will direct that output and show you. Right. Okay. So that's all. So sorry. Okay. So when I want to run this, all I need to do is I can close down everything in front. Okay, I can stop. I can stop this. I can stop the sound play node. I can even stop the call. So there's no call, nothing run, and I just run ROS launch, which is every time when you run ROS launch, you don't need the call, because every time when you run ROS launch, if your call is not running, it will run the call first. Okay. Then package, and then I put the sound test.launch. When I run it, I'm going to hear a series of sound.
Hello world.
Yeah.
Beep.
Yeah, that is the sound effect. Not sure if you can hear, but this. Okay, so basically these are all the sound effect that is written just now in the soundtest.py. Okay, right. Okay, so with that, I already show you the example of speech synthesis using the sound play node. Okay, so before I jump into another part, if you have any question, yes, feel free to ask me now. Yeah, you can ask me now if you have any question before I jump to another session. Is there any? Do you have any question? Any of you? Do you have any question? You can follow up to this point. No problem. Am I too fast or too slow, or you actually have no idea what am I talking about? Feel free to feedback to me. Right. So if you have no problem, then yeah, I'll proceed. So just now I show you using this festival and sound play package, we can create sound, okay, by specific the speech, right? The text, then it can take out, it can speech out. Okay, so just now, if you can hear the sound generated, for example, the hello world and so on, it is a very male machine sound. So just in case you want to change, okay, you can actually change to other kind of sound profile. For example, you want a lady sound, you want a children sound, and so on. Yes, in Festival, you can actually add more sound package, okay, or sound file. Okay, you can install by devs, you can install by the sound voice file, which is over here I list down, and then I even put here female voices. These are all the female voices that you can try. Right. For more detail, you can read this Ubuntu forum, this page. It tells you a lot of detail, right? So, but yeah, just in case you're interested, and you can specify the voice over here. There are actually many ways to specify what voice to use, but if you don't specify, it will use the default one, which is the one that we hear just now, right? You can specify. Okay, so this information is just for your interest, because I remember like many people actually ask me like, can I actually change the sound? Yes, you can. And you can even change like multiple, like your robot can actually speak different languages so that you can create a robot to tell a story, and the robot can actually role play different character by saying things differently and so on. Yeah, so yes, you can do a lot of things with this. Just the sound play. You can do a lot of application. Yeah. I think a storytelling robot is very interesting if you know how to really use this sound play package and create different sound and create different delay and tell story in a different way. Yes, with just this sound play, you can already create a service robot application, like a storytelling robot. Right. Okay. So this is the offline way, which is you don't use any online resources. So before I finish this session, which is finish part A, which is we discussed about speech synthesis, I'm going to show you a second way to do this thing. Okay, a second way, which is this approach is much more popular. Okay, because the sound generated maybe nicer. Okay, just now the festival and the voice file, those are open source. So maybe the quality is not very, very high, but this one, okay, the example that I used by Google. So Google got two types actually. I searched, then it got the cloud speech API, and this one is the web speech API. Okay, so they are a bit different, but they are both from Google. Okay, but you can use other things, right? There are actually many online speech synthesis or text-to-speech services. Okay, for example, Mozilla got the web speech API, IBM also got many other things. Okay, many other companies that provide these text-to-speech services. Some are none are open source. Okay, none open source. These are all commercial services, but some you really need to pay. For example, Google, you need to pay when you heavily use this function. They have a limit for free access. Okay, so if you use it for production, for example, you build a robot and sell the robot, and you're using the Google speech, yeah. If you use it for production, then you might need to have the premium service. But for us, when we do learning, you can use the free test version. Okay, so this is the education things, the free access version that we can use for our research and also study. Okay, so so now I'm going to show you this. And remember, when you use any online way, your robot have to be able to access to the internet, which means able to connect to the service provider. For example, here the service provider is Google. So in order for you to get this function, okay, so over here we can install this. Okay, so those that use virtual desktop, you no need to install because already installed. Okay, so for those of you who haven't or you set up by yourself, you can install with this Python project. So you can install by setup. So I already like put down even how to set up. So you pip install the GTTS, which is Google Text to Speech. And then you also need the MPG321. This is actually a player, okay, to play the sound. Okay, because Google Text to Speech actually send a WAV file, if I'm not mistaken, or create a WAV file. Then after that, you need this MPG321 to play it. Right. Okay. So with this, let me show you how this thing look like. Sorry. Okay, let me close all my terminal. Okay, right. So again, I show you the sample code and also the execution. So let me show you the execution first. Okay, so first ROS call. Then run the node. This one, RC home speech. Okay, so in the same package, I have this example as well. So under the RC home edu speech package, we have this Google TTS. Yeah, Google text to speech.py. Right. So when I run this, okay, nothing happened. Don't worry, it's running. Right. We didn't write an indication showing that it's running, but if nothing showing here is good. Okay, so which means it's running. Then I open another tab. Okay, so this is the time I need to publish the script. Okay, so let me just show you the ROS topic list. You can see we have the ROS out, which is this one belongs to the ROS system, but we have something new which is called input. So this input, later on I will show you this input topic. So this input is basically the topic that is listened or subscribed by this Google TTS. So this Google TTS node, it will subscribe to this input topic, and every time you pass some data or message into this input, then it will read it out. Okay, it will synthesize and show you the and perform the text to speech. Right. So I use the ROS topic. You can write a note to do this, but just for simplicity, I use the publish. So this one means I publish into this speech input, topic input, and then the format is a standard message string. And I don't need to type, I just type and it come out, all right? So the data that I'm going to put in is, again, I put the same thing, hello world. Right, okay, so when I run this,
Hello world.
Yeah, I can hear a female voice, hello world. Okay, this one is by the Google Web Speech API. Right, okay, so and then I can do something like, hello, how are you?
Hello, how are you?
Okay, yeah, I can make it longer, but this time, because I want you to show, okay, so over here, I want you to listen carefully. If let's say it happened at your terminal, I'm not sure if you can hear my speaker, but if you're running on your desktop, then you're supposed to hear it. You may notice that if I put punctuation, it actually gives me different pronunciation.
Hello, how are you?
Now I can hear the speech is actually divided into two sentences. Hello, then it stop, pause a while, then how are you? So which means just now when I say in the first slide, you got analyze the linguistic analysis and so on. So over here, it actually look at the punctuation mark to give you the appropriate. And even I put a question mark here, it actually gives me a different, the ending sound actually higher, which indicate a question, right? Yeah. So the quality that given by this Google text speech is relatively high and is very nice. Okay, so I hope you can try on this. And now let's look at this Google text to speech. Okay, so ROS CD RC, I can straight away jump to my package, and then I go to the script, and then I can show you the text to speech. And you can see it's very, very short as compared to just now. But this is the online service. So you have no idea what happened, right? You have no idea because what happened here is like you can see up here is just some import and also get the library thing. And then it got a callback. So it is very similar format for your subscriber because it's a subscriber. So you can see this over here, we initiate the node and then we have a subscriber, the subscribe to the input, right? Subscribe to input. So this input is the topic. So that's why we have the input topic just now. And whatever that we publish into this input, it will be sent into this callback. So the callback is over here. So when the input is print out, okay, so what is the input data? And then it actually put into this GTTS. So this is the Google function. So you put your input, which is a text over here. It need to be string, so data. So it put into this GTTS. So it saved as a MP3 file. Yeah, so which means it you send the text to Google, and then the Google will save, okay, the result into a speech.mp3 file. So it create an MP3 file, and then you OS using the MP3 321 MPG, sorry, MPG 321 to play the speech. That's why we can hear the sound, right? The speech. Then we remove the speech, the MP3 file, because we don't want the file. We just want to hear the text to speech, right? Yeah, that's all. So this is just the example. It's nothing complicated. I believe everyone over here, as long as you have some knowledge about Python code or about programming, you can really understand everything that I say just now. Okay, so with that, I finish my explanation for the part A of today, and the time is also 8:30. So for assignment, for your exercise, you apply the ROS publisher and subscriber into the sound text. Okay, so just now the sound test example, it just when you play, just play all the sound. Okay, but if for your application, because later on you are going to integrate this function into other function, so this exercise will serve as the first step for you to integrate this sound function with your other function, right? So first you develop a node to publish a sentence to the topic, right? So instead of just a ROS topic from the terminal, you create a node that publish, right? Publish the message. And then you create a node that subscribe to the topic and read out the sentence. So very similar like what I just showed you in the Google text-to-speech. It subscribes to the input topic and then you read out, right? And then you display the result. But this one, you do it for the offline sound text, which is using the sound play function or sound play software. Then, of course, you can practice to upload to GitHub. Right. Okay, so with that, I have finished the first half of today's class. Okay, so let me come back here. And I would like to know if you have any question, okay? So I would like to take about a 5-minute break. I would like to ask if Jupyter Robot, you want to show some demo?
Okay.
Okay, right. Okay, so Jupyter Robot is ready. So we are going to break for about 5 minutes time. And just now I show you the offline using the SoundPlay, and then the online using the Google text-to-speech. Both got with the example and the source code, everything is already there for you to refer. Now I would like to invite Jupyter Robot to show us if we want to do the speech synthesis in Chinese. Okay, so how to do it? Right, so can I invite Jupyter Robot to show us the example? Then, yeah, can you share your screen first so that people know what you're running?
Okay.
Okay, right. Share your screen. Good. Okay.
Right now or after 5 minutes?
Okay, so I can see this is the Jupyter OS. All right, so this is the Jupyter OS. This is the system that run within the Jupyter Robot or within the I/O, right? Okay, so you have the system. Okay, so it's very similar.
Okay. As you may know, in the workspace of our Jupyter OS, there is another online speech package here called XFAE ASR. Here we.
So this is the Xunfei, which is iFlyTech online speech service.
Yes. Here we got some code like TTS and ASR. I'm just gonna show how to use this package.
Okay, right. So now let's show the TTS part. Okay, ASR, which is automatic speech recognition, we'll do it later, right? So now let us see how we do the Chinese speech synthesis using the iFlyTech or Xunfei software or service.
Okay, open the terminal and type in rows call.
Okay, so
then then we type in the command like rows run package name. Then
so can you see it's very similar like the SoundPlay. Okay, so we run the call, we run a node to start the text-to-speech function, then we publish the message to the node. Yeah, very similar. So now we use the ROS topic list. We can see there's an XF word. So this is the input topic for Xunfei. Right. So now then what Dan is trying to do is very similar like what I did in SoundPlay. So you send a message into this XF words topic. Yeah. Okay. So you are going to. Okay. So you are reading English word. How about Chinese word.
Okay.
Yeah. Okay. Write something longer. 可以写吗？
可以。
Okay. Okay, good.
好。
不要放标点符号。
不要放啊。OK。
You can erase and tap again. Okay, right. Okay, so I can hear it very clearly, right? So yeah, it read the text in Mandarin and then it read out in Mandarin, right? So this is for because this iFlyTech services is mainly for Chinese speech synthesis and also speech recognition. So the pronunciation is very accurate for Chinese words or Chinese sentences. So for those that you want a different languages, yeah, there are actually plenty of this speech API available. I'm not sure about Thai, so for the audience today, if any of you have any experience how to do this in Thai language, because personally I don't know how to read and write Thai, so it's not really possible for me to develop something using the Thai language. But if any of you in the audience know how to do this in Thai, I would like to invite you to share with all of us here also, right? Okay, but before I go further, is it done? Jupiter Robot, done, right?
I going to show the ASR.
ASR, we do it after this, okay?
Okay.
Next. Right, so we do the ASR after this, okay? So we will stop it here. We do the ASR after this, okay? All right, thanks, Dan. Okay, so can I have yeah, my translator committee member, right? So can you please summarize what we have done here, and also if we would like to ask the audience if they have anything they want to ask, and also if anyone familiar to do speech synthesis in Thai, I would like to invite you to share the information with us. Okay?
โอเคครับก็เมื่อกี้เขาก็ได้ทำการโชว์วิธีการใช้แล้วก็มีทั้งออฟไลน์แล้วก็ในส่วนของออนไลน์แต่ว่าเท่าที่ผมเคยทดลองมาในส่วนของออฟไลน์เนี่ยยังไม่เคยเห็นภาษาไทยเหมือนกันนะครับแต่ว่าตัวออนไลน์ตัว Google ที่เป็นเพจชุดสปีดเนี่ยมีภาษาไทยนะครับสามารถใช้งานได้นะครับแล้วก็หากหรือว่าท่านใดเคยทำที่เป็นภาษาไทยเนี่ยก็สามารถที่จะเปิดไมค์ขึ้นมาพูดคุยกันได้เลยนะครับแล้วก็ใครมีคำถามอะไรก็สามารถยกมือขึ้นมาถามได้เลยเช่นกันนะครับโอเคเจฟฟี่
All right. Okay, so anyone got any question to ask or anything you want to share before I proceed to the next part? Anyone? Anyone? Any question? Yes? Yeah, I saw someone put up your hand, so please turn on your microphone to interact with us.
Can I ask in Thai language?
Yes, sure. Please ask.
ขอถามหน่อยครับว่าตอนที่เขาโชว์การใช้ตัวแพ็กเกจที่เป็นออฟไลน์ครับเห็นว่าเป็น Python 2 แต่ว่าจะถามว่าสามารถใช้เป็น Python 3 ได้หรือเปล่าครับ
คือตัวแพ็กเกจที่เขาโชว์ให้ดูเป็นตัวอย่างนะครับมันถูก develop ผ่านบน Python 2 นะครับน่าจะไม่ได้เหมาะสมกับ Python 3 แล้วก็อีกอย่างหนึ่งอาจจะไม่ได้เหมาะกับการรันบนUbuntu 20อะไรประมาณนี้ด้วยครับเพราะว่า ตัวเบสใน ROS ที่เขาเขียนเนี่ยเขาต้องการใช้ตัว ROS ไฟล์ที่เป็นบน Python 2นะครับแต่ว่าถ้าเป็นUbuntu เวอร์ชัน20ขึ้นไปหรือว่าใช้ ROS เวอร์ชัน Robotics ขึ้นไปเนี่ยตัว ROS บน Python 2เนี่ยจะไม่สามารถใช้งานได้ครับ
โอเคครับเคลียร์ครับขอบคุณครับ
Yeah, may I know what is the question about?
He wants to know that is your code can use in Python 3?
Okay, yes. The software that I introduced, you can run on Python 3 as well for the PIP. You can run on Python 3, but for ROS, because we're using version 18, so version 18 is Melodic, which is Ubuntu 18.04. It is in between Python 2.7 and 3, right? So there's a way you can compile everything in Python 3. Yes, no problem, but you need to know how to do it. For us, currently, we are running the example that I show you is actually run on Python 2.7, right? But the software that I show you, for example, the Google and all those example, it can actually run on Python 3. Yeah.
Thank you so much.
Yep. Right. And any more question? Yeah. I apologize because I can't show you example that speak in Thai. I can't do it myself also, but yes, so for our committee member and also our community member in Thai, so if let's say you have such example, feel free to share with us. Okay, right. So if you have no more question, I'm going to start the next session. Okay, so I'm going to switch my slide to the next part B.